You check your weather app to see if you need a jacket, and right below the temperature, there it is, a bright red warning that reads 155, unhealthy. That number represents a staggering volume of data tracking airborne contaminants, particles and gases linked to chronic lung disease, and billions in annual economic losses. Because we can't see the invisible chemistry involved, we often overlook the massive scale of what we're actually breathing. Much of it comes from the infrastructure of modern life. These smokestacks represent heavy industrial output and the constant combustion of fossil fuels, dumping massive concentrations of pollutants into the slipstream. Natural events are increasingly adding to that load. The rising frequency and intensity of wildfires can saturate an entire region's atmosphere with smoke and ash in a matter of hours. To make sense of these overlapping threats, we created the Air Quality Index. It functions as a translation tool, stripping away the complexity of atmospheric chemistry to provide a single, actionable score. When you step outside, the AQI isn't measuring a vague level of dirtiness in the air. It is tracking a highly specific and highly reactive cocktail of major pollutants. This diagram shows exactly what we're inhaling. We start with the width of a single human hair, scale down to a grain of sand, and finally down to these microscopic dots. These are particulate matter, PM10 and PM2.5. They are small enough to bypass your body's natural defenses and slip directly into your bloodstream. Alongside those solid particles, the air is laced with invisible, toxic gases. The index constantly monitors nitrogen dioxide from car exhaust, sulfur dioxide from power plants, and ground-level ozone. To capture this cocktail, cities rely on continuous ambient air quality monitoring stations. These physical ground sensors sit out in the elements, continuously pulling in air and measuring the exact concentration of each chemical. But the ground sensors aren't working alone. Orbiting satellites bounce scanning beams through the atmosphere to measure aerosol density from space. The ground readings and the satellite data merge into a massive planetary web. Every time you check that number on your phone, you are looking at the results of a continuously running, real-time chemical biopsy of the Earth's atmosphere. Here is how that atmospheric biopsy actually translates into your daily score. Every individual pollutant, whether PM2.5, ozone, or sulfur dioxide, gets graded on its own independent scale. But the AQI is not an average. The system takes a worst-case scenario approach. Whichever single pollutant spikes highest dictates the entire score for your city. That final number is then dropped onto a standardized color scale. If the score lands between 0 and 50, you're in the green zone and the air is clean. Creep up to 100 into the yellow, and slight risks emerge for sensitive people. Once the dial crosses 150, the color turns red and physical symptoms begin. A healthy adult might step outside and immediately experience coughing, throat irritation, and a distinct difficulty pulling in a full breath. If the score breaches 300, the air turns hazardous. These are emergency conditions. Thick smog hangs in the air, and stepping outside without a mask poses immediate dangers, especially to the elderly and children. Every point on this scale correlates to a specific level of physical damage occurring inside the human body. The AQI is a direct mathematical measurement of biological risk. When we zoom out to a global view, distinct patterns emerge. Rapid urban growth and unregulated industrialization mean that developing nations frequently endure the highest and most dangerous AQI levels on the map. Take Delhi, India. Every autumn, surrounding agricultural regions clear their fields by burning the leftover stubble. This massive, coordinated combustion releases millions of tons of particulate matter into the air. As the temperatures drop, a weather phenomenon called a winter inversion acts like a lid over the city. It traps that agricultural smoke, along with urban exhaust, directly at street level, triggering hazardous AQI spikes that block out the sun. But high wealth doesn't automatically buy clean air. Los Angeles still struggles with persistent smog. Here, millions of combustion engines burning gasoline in dense traffic patterns keep local ozone and particulate levels constantly elevated. Look at this visual comparison of Beijing. In the top panel, severe industrial smog completely obscures the skyline. By enforcing aggressive pollution controls, shutting down coal plants, and heavily regulating vehicle emissions, the city dramatically cleared its skies, as seen in the bottom panel. The air you breathe is rarely an accident of nature. Your geography, your local economy, and the strictness of your government's policies directly dictate the toxicity of your lungs. Lowering a region's AQI takes massive coordination. It requires sweeping international agreements, like the Paris Climate Accords, backed by strict, legally enforced national emission limits. It also requires hardware. Transitioning transportation grids away from internal combustion engines and building out the infrastructure for electric vehicles immediately cuts down the nitrogen dioxide choking our city streets. On a local level, communities are planting dense urban tree canopies to naturally filter particulates, while individuals use daily AQI apps to know exactly when to stay indoors or wear a mask. Soon, our response will shift from reactive to proactive. Smart city sensors are feeding vast amounts of local data into AI models, allowing governments to predict pollution spikes days before they happen and restrict industrial output to stop the smog before it forms. The AQI offers a real-time account of our atmospheric health. With the sensors active and the data clear, the remaining challenge is purely political, using these numbers to enforce a future where we no longer have to fear the air we breathe.